Hello and welcome to GRACE tutorial. In this video lecture, we will be discussing about the carboxylic acids. And here we will discuss the carboxylic acids and the functional group of the carboxylic acids, the nomenclature of the carboxylic acids as well. So if you look at the carboxylic acids, what is the carboxylic acid RCOOH? That is what basically the general formula of the carboxylic acid, that is RCOOH. In RCOOH, the R is an alkyl group or aryl group. So in the RCOOH, what is this R? R is basically an alkyl group or aryl group. Well, so this is what basically the functional group of carboxylic acids, or the general formula RCOOH. In this RCOOH, here what is obtained here, what is observed, we know that the carbonyl group, CO means it's a carbonyl group, and OH, CO, that is carbonyl group. And OH, hydroxyl group. Yeah. So when the carbonyl group and hydroxyl group reacts together, that means if you will add the carbonyl group and hydroxyl group, then that is called the carboxyl group. Individually, the CO means carbonyl group. Here R means alkyl group or aryl group. You understood, I think. CO, this is carbonyl group, which we had already discussed here in the first lecture of the aldehydes as well as the ketones. Carbonyl group CO, and OH means hydroxyl group. And when this hydroxyl group and carbonyl group are mixed, then the group which is obtained is called carboxyl group. That means here this is all about the carboxyl group. So what is this carboxylic acid means? What do you say? Carboxylic acids are the organic compounds which contains both the carbonyl group as well as the hydroxyl group. Or you can say the carboxylic acids are the organic compounds which possesses the alkyl group along with the carboxyl group. Now let us look at some of the examples of carboxylic acids. Carboxylic acids have been classified into the various categories on the basis of the number of carboxyl group attached to that. Suppose, let me write here, that is RCOOH. This is carboxylic acid. This is the general formula of the carboxylic acid we know. If I will write here CH3COOH, this is a monocarbozylic acid. This is acetic acid, but it comes under which group? It comes under the monocarbozylic acid, because here the carboxyl group is 1. That's why it is mono. But if I will write here since the two carboxyl groups are present, that's why this is called the dicarboxylic acid. Similarly, three carboxyl groups are present. That's why this compound is a tricarboxylic acid. Suppose we have only carboxyl group. This is called oxalic acid. That means the carboxylic acids can be classified into the various categories on the basis of the carboxyl group which is attached to that. If the carboxyl group is 1, then that is known as the monocarboxylic. If the carboxyl group is 2, then that is dicarboxylic. If the carboxyl groups are 3, then that is known as the tricarboxylic. So mono, di, tri, and if both the carboxyl groups are there, we are having not attached to any of the carbon atom, that is oxalic acid. So I hope you understood that what do you mean by the carboxylic acids. Well, the carboxylic acids are the organic compounds which contains both the carbonyl group as well as the hydroxyl group. in which we can say which contains the alkyl group or aryl group with the carboxyl group. So on the basis of the carboxyl group, on the basis of the number of the carboxyl groups, the carboxylic acids have been classified into mono, di, tri, etc. So this is monocarbozylic acid, dicarboxylic acid, tricarboxylic acid, and this is oxalic acid. This is the basic introduction of the carboxylic acid. Now we will look at the most important thing, that is the nomenclature. Nomenclature of this carboxylic acids. In nomenclature, what we need to understand, first of all, you need to put the formula. Based on the formula, and here you have structure, and here you have common name and IUPAC name. Yeah. So based on the general formula RCOOH, this is the general formula RCOOH. So if you will place a hydrogen atom here in the place of R, what the formula is obtained? The formula is HCOOH. But in the structure wise, we need to write HCOOH. So what is the common name of this compound? Since hydrogen is attached, so we can say form. And since the acid group is obtained, that's why you need to add IC, that is formic acid. Yeah. So what is the name of the compound HCOOH? The name of the compound HCOOH, formic acid. And the formula is HCOOH, and this is what I have written here in the form of the structure. So what is the IUPAC name? The International Union of the Pure and Applied Chemistry. The name is, you always remember, the IUPAC name will be given on the basis of the number of carbon atoms which is present there. So how many carbon atoms are there? One carbon atom is there. That means you need to say methane. Here in this methane, what happened? Since the acid groups are attached, so the suffix will be oic acid. You need to remember, this oic acid is the suffix. So eliminating this E, you need to add OIC acid. So what's the name? Butanoic acid. So this is the first member of the carboxylic acid. If you look at the second member, if you will place the methyl group in place of, in the place of this R, what is obtained here? CH3 CH3COOH. CH3COOH, and structure wise you need to write here CH3COOH. Yeah. And if CH3 is there, means obviously you can say acid, and IC, that means acetic acid. So CH3COOH. So what is the name of that compound? Acetic acid. And IUPAC name can be given on the basis of number of carbon atoms which is present on them. So how many carbon atoms are there? 1, 2, 2 carbon atoms are there. So you need to write first of all ethane. Now the removing E, then you need to add here oic acid, because which is what the suffix of the carboxylic acid. So what is the name of the compound right now? Ethanoic acid. So ethanoic acid is basically the IUPAC name of the compound. But what is the common name? Acetic acid. You need to remember both the names, that is common name as well as the IUPAC name. And in the examination point, most of the questions may come from using the common names. But why the IUPAC name is very important means one compound is given and name the compound according to IUPAC system. That means you need to remember how to name that compound, and if the compound CH3COOH given, then you need to name it as ethanoic acid. Given the structure is given, the compound is given, and to identify the name, and that is also on the basis of IUPAC. That's why, and for that regard, the IUPAC is very much important. And common name is also very important. Why? Because using this common name, many of the questions may come in the examination. That means if I will ask you that when the acetic acid reacts with alcohol, what happens, which product is obtained, that you need to remember it very well. Acetic acid means immediately that you need to remember CH3COOH. That's why both the common name along with the IUPAC names are very much important, but the uses are it in different way. And the next member that we have, suppose if you will place another alkyl group, that is ethyl, that means C2H5COOH. If you will put here CH3 CH2 COOH. So what is the name of this compound according to this common name? Common name is, you see, if ethyl group is attached, then no doubt you can say propione. And at last you should add IC acid. In common name, the suffix that you need to add is that IC acid. But in IUPAC name should be given on the basis of number of carbon atoms present. So how many carbon atoms are there? 1, 2, 3. 3 carbon atoms are there. So 3 carbon atoms are there means obviously you can write propane. And what you will do, you will remove this E and you need to write oic acid because that is the suffix. And the name of the compound is propanoic acid. Yeah. But what is the common name? Propionic acid. The common name is propionic acid, but the IUPAC name is propanoic acid. Suppose if you will add one more alkyl group, that is C3H7 COOH, or you can write CH3 CH2 CH2 COOH. So what is the name of this compound according to the common name? If this is propyl. If ethyl is there means you need to write propione. Similarly, if propyl is there, you need to write butyl. And at last you should add IC acid. That means butyric acid. So what is the common name of this compound? The common name of this compound is butyric acid. Yeah. So IUPAC name should be given on the basis of number of carbon atoms present. Now you tell me how many number of carbon atoms are there? 1, 2, 3, 4. So 4 carbon atoms are there. So if 4 carbon atoms are there, then what do you say? You need to say butane, and removing this E, that you need to write oic acid. That means what is the name of this compound now? Butanoic acid. So the butanoic acid is an IUPAC name and the butyric acid is a common name. So common name is very important. Why? Because it comes in the examination. Suppose the butyric acid, when the butyric acid reacts with the butyl alcohol, then what results? Or the butane, the structure is given like this: CH3 CH2 CH2 COOH. Name the compound on the basis of IUPAC system. So in this way, IUPAC as well as the common name, both are very much important to remember. And let us look at the last number. Suppose if I will add one more alkyl group, that is C4H9 COOH, and structure either I have did CH3 CH2 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 COOH, and this is what you have butyl, because 1, 2, 3, 4 carbon atoms are there, so butyl. So here you need to write valeric acid. So valeric acid is the common name of the compound. But what is the IUPAC name of the compound? The IUPAC name of the compound is very simple to understand. That IUPAC name will be given on the basis of the number of carbon atoms. So now you recognize that how many number of carbon atoms are there? You count 1, 2, 3, 4, 5. So 5 carbon atoms are there. So if 5 carbon atoms are there means what will be the IUPAC name? I think that you already guessed it, right? So 5 carbon atoms are there means obviously you can say that is pentane. And in the pentane, since the acid group is attached, carboxylic group is attached, that's why the E is removed here, and what will be added? Oic acid. That means now what is the name of this compound? Pentanoic acid. Yeah. So C4H9COOH, and this is, this is the structure. But what the structure that I have shown here, this structure is a condensed structure. You should know that this is a condensed structure. Condensed. But this is not an elongated structure, or this is not an expandable structure. This is not an amplified structure, but it's a condensed structure. The structure which is written in the short way. That's a condensed structure because it has been condensed. Well, the name of this compound is valeric acid. Common name. But IUPAC name is pentanoic acid. That means what have we learnt here? We have learnt here the nomenclature of monocarbozylic acids. Nomenclature means the naming of the compounds. So how the naming of the compounds will be given on the basis of the general formula. So the general formula of monocarbozylic acid is RCOOH, wherein one alkyl group or one aryl group will be present. Putting the hydrogen or the various alkyl groups in the presence of this R, so instead of this R, then we find the various formulas as well, along with the structure and the name of the compound, common name along with the IUPAC name. That's what all we did here in the nomenclature of this compound. Let me tell you, let me give you some another examples of, let me give you some other members of the carboxylic acid. That means if the substituent group is attached to the member of this carboxylic acid, then how the name will be given? Let me show it for you. Here, look at here. Suppose I will write one formula for you, that is CH3 CH2 CH CH2 COOH. Yeah, this is basically a compound. Now the question is, name the compound on the basis of IUPAC system. In this way the question comes in the examination. In the basis of IUPAC system, you name the given compound. So the naming is very simple. You see, 1, 2, 3. So if you will count here, in the third number position the methyl group is there. This is 4 and this is 5. So in third number position, since the methyl group is there, that's why what you need to say, that is 3-methyl. 3-methyl, first of all, the substituent is to be named. So 3-methyl, 1, 2, 3, 4, 5. So how many carbon atoms are there? 5 carbon atoms are there. So 3-methyl, you can say pentanoic acid. Pentanoic acid. So this is the name of the compound on the basis of the IUPAC system. 3 number position methyl group is there. That's why 3-methyl pentanoic acid. Suppose one more methyl group is attached here. Suppose you see one more methyl group is attached here. Then what do you say? 3,3 dimethyl pentanoic acid. Because 3 number position both the methyl groups are there, so 3,3 dimethyl pentanoic acid. Suppose you see in position number 2, in position number 2 one more methyl group is attached, suppose. Now you tell me what is the name of this compound. The name of this compound is 1, 2, 3. That means in position 2 and in position 3, the methyl groups are attached. So what do you say? 2, 3 dimethyl, because 2 methyls are there. So 2, 3 dimethyl, 2, 3 dimethyl, and the main chain is pentanoic acid. So this is the name of the compound. on the basis of the IUPAC system. So what you need to remember here, most importantly, naming in the form of IUPAC system, first of all, that you need to remember that how many carbon atoms are there. The first point. And second point is that what are the substituents attached to that, because these substituents are named first of all. Substituents means the substances which are attached to the carbon atoms, or it's like a branching. That means since the CH3, these CH3 groups are attached to the carbon atom, therefore these are the substituents. So if you look at here, the substituents, first of all, the substituents will be named according to the rule. Then after, the main chain, or we can say the principal chain is to be named. In this way, the compounds are given, and that you need to identify the IUPAC name of the given compound. So in this way, the common name along with the IUPAC names will be helpful a lot to remember much more regarding the preparation along with the chemical reactions of the carboxylic acids. Now we will go to the isomerism of the monocarboxylic. If you look at the isomerism, well, before in the lecture of the aldehydes as well as the ketones, I had explained you in a very detailed and the systematic manner about the isomerism and the various types of the isomerism. Here directly we come to the point that the carboxylic acids show the different isomerism. The first one we have the chain isomerism. So what is basically the chain isomerism? When the compounds having the same chemical formula but differ in their chain. That means chemical formula is the same but differ in chain. So that isomer, those isomers are called chain isomers, and the phenomenon is called the chain isomerism. Let me show you the example. Look at here, 1, 2, 3, 4. 4 carbon atoms are there, and acid group is attached. So what is the name of this compound? The name of this compound is butanoic acid. Butanoic acid. Now you look at here, another compound is there, wherein 1, 2, in position number 2 methyl group is attached. That means 2 methyl 1, 2, 3 propanoic acid. 2 methyl propanoic acid. So if you observe these two compounds carefully, both the compounds possesses the same chemical formula. How many carbon atoms are there? Total 4 carbon atoms. Here also total 4 carbon atoms. How many hydrogen atoms are there? 3, 5, 6, 7, 8. And 3, 4, 5, 6, 7, 8. So total 8 hydrogen atoms are there. 2 oxygen atoms are there. That means the chemical formula is the same. But what is different here? The chain is different. Here it is a straight chain. But this consists of a branched chain. So the compounds having the same chemical formula but differ in their chain comes under the isomer, which is called the chain isomers, and the phenomenon is called the chain isomerism. So that's what. And the point 2 is that the carboxylic acid also, it shows the functional isomerism. So what is this functional isomerism basically? Those compounds having the same chemical formula. Chemical formula is the same, but what is different here? The different is functional group. Functional group will be different. How? Look at here. Here suppose I have written CH3CH2COOH. What is the name of this compound? Since 3 carbon atoms are there, that's why this is propanoic acid. Propanoic acid. And this is propanoic acid, and this one 1, 2, 3. 3 carbon atoms are there, no doubt. But this is, this is the member of ester group, because ester, RCOOR. This is ester, wherein 2 alkyl groups are there. 2 alkyl groups are there, and ester is there. That means methyl acetate. We can say methyl acetate, or you see, 1 methyl ethanoate. You also can say methyl ethanoate on the basis of IUPAC system, but on the basis of common name, methyl and CH3COO means acetate. That means the chemical formula, both these compounds are same. But what is different? The different is that here the functional group is carboxylic acid group, and here the functional group is ester group. That is what called basically functional isomerism. The compounds having the same chemical formula but differ in their functions. chemical formula should be same, otherwise that cannot be called as isomerism, because iso means same, meros means parts, the same equal parts should be there. Well, it also shows the optical isomerism. Basically, you see, the isomerism are broadly classified into two types. One is structural isomerism, another is stereoisomerism. In the structural isomerism, we have various isomerisms. We have chain isomerism, we have position isomerism, we have functional isomerism, which we have discussed in the previous lectures in aldehydes as well as the ketones. And if you want to know about the isomerism along with the specific examples with the various types along with the examples, I request you to go back to the previous lecture of aldehydes and the ketones so that you can get it. So what I was telling to you is that structural isomerism and stereoisomerism. Structural isomerism is divided into number of types, subtypes like chain, functional, position, ring type, and metamerism, tautomerism, etc. But stereoisomerism is further divided into two types. One is geometrical isomerism, another is a optical isomerism. So what is this optical isomerism? The isomerism, the compounds. In case of this optical isomerism, there will be a spatial arrangement of the atoms in the 3D space. Yeah. So arrangement of atoms in 3D space. That's what here we will discuss the optical isomerism. But in optical isomerism, how? Suppose you see one compound is there. Yeah, in this compound, basically what happened, if you will put that compound in front of the mirror, that means there is a mirror in front of the compound. Can the position of the compound will be remain same? No. Here the positions will be something, it will be alternative. That means look at here. Here hydroxyl group is there in the right side, but here the hydroxyl group is there in the left side. How? Because if you will stand in front of the mirror, your right hand will be appeared there in the left hand side, will be left side, and your left hand will be appeared there in the mirror in the right side. In the exact way, if you will put this compound in front of the mirror, then the hydroxyl group which is present there in the right side, it appears to be in the left side. Similarly, you see, you have hydrogen which is there in the left side, but if here the hydrogen is there in the right side. That means the compound, if it is placed in front of the mirror, then slightly there will be an alternative image which is formed of this compound, and that means that optical isomerism also can be shown by the carboxylic acids. In this way, the carboxylic acid shows both like a chain isomerism, functional isomerism, along with the optical isomerism. So this is what all about the isomerism which is shown by the monocarbozylic acids. Well, that's all about today's session. And in the next video lecture, that we will be discussing about the methods of preparation of the monocarbozylic acids along with its chemical properties. Anyhow, thank you very much for watching, and if you'd like to watch these types of the videos, I request you to press the bell icon over here to subscribe to our channel to get the latest notification. Thank you very much for watching.